Hi. So in this video, just I'll try to learn about 3D rasterization and how uh, Unreal's Nanite engine works. So like uh, I have read a few things about it. Now I'm making this video just to sum up everything, just to draw a conclusion in my mind. So I could have just written things down as a summary, but I think if I make a video, then I have to like, I think making the video will give me more conceptual depth. So let me start how I landed here, why I am making this video. So I'll share my Chrome tab. So I was looking at this video, Tim Sweeney, who is the CEO of Epic Games. I was looking at his podcast. Now he was mentioning about the Nanite engine, Unreal's Nanite engine, uh, he which is kind of a breakthrough in the world of 3D rendering. Now, uh, so when I learned about it, I then tried to know more about how the Nanite engine works. So here is what I have learned so far. Firstly, what was the problem so far in the 3D rendering industry or 3D uh, in the 3D rendering industry? So suppose there is a game now. Suppose there is an open world game. Now, suppose there is this tree, right? I am standing far from this tree, like it is say 5 kilometers away from the tree. So I don't need to render it in very high definition, right? Because like there can all the 3D models in my game can have the most like can have the best of poly count, but if I want to render everything, then it will be very costly for my rendering engine. So the general uh, concept in rendering is that just render what is necessary, don't render the unnecessary stuff, right? So suppose a tree is far back from me. I don't want to render all the details of the tree, so might want to render a low poly version of the tree. If I'm closer, I can try to render this one. Further closer, this one. More closer, this one. And this is when I'm extremely close to the tree, I can render this model. Now, how this usually happens in normal game engines is that you have to create five versions of this model of the tree, and you can configure things. Okay, if it is 5 kilometers, then this show this. If it is 2 kilometers, then show this, like that. Now the problem here is that there would have been sharp transitions, right? Because suddenly when I'm at the 5 kilometer mark, when I'm at the 2 kilometer mark, there would be a sharp transition between this model and this model, and this led to loss of realism, right? Loss of immersion for the game, for the gamers. Now, how did they solve it? I again, this is I have just I couldn't read through it in much detail, but I'll just tell what I understood, right? So instead of going by this model, like which is discontinuous, we can go with a much more continuous thing. So how Nanite uses a different approach to rendering polygon in real time called visualized geometry, which works by implementing individual clusters on an object. Implementing individual clusters on objects. The less detail that an object is required to have, the larger the surface area of the individual clusters. Right. Each cluster has their own polygon, uh, as shown in the image below. So, suppose. This is what I understand. Suppose this is the whole 3D scene. Now, The clusters render their polygon independently based on the distance from the player. So the object has the maximum level detail needed for every depth of the object. ठीक है? As the player moves, the individual cluster dynamically adjusts their polygon count depending on distance visibility. This saves processing power tremendously because an entire object does not have to be rendered at the highest level of detail possible. Only the closest parts of the player, the code, ठीक है, the clusters render their polygon independently based on the distance from the player. So what I understand here is that if the player is far, the poly count of an individual cluster reduces. This part I understand. So the object has the maximum level of detail needed for every depth of the object. Cool. As the player moves, the individual clusters dynamically adjust their polygon count depending on the distance visibility. So this also I understand that if the camera is closer to a particular cluster, the poly count of that particular cluster increases, which is also what like I understand this part. What I didn't understand is these about the surface area of this cluster. So uh, the lesser detail that an object is required to have, the larger the surface area of the individual cluster. This is what I didn't understand. So is it that if the object is closer, then the individual surface area of the cluster also increases? Is that the case, or it's just that the it's just that the poly count inside that cluster increases? So this part I didn't understand. I'll just try to understand it from GPT. From above observed have a doubt. Does this mean that the cluster surface area and the poly count of each cluster both are dynamic, or is just the poly count of each cluster dynamic? In an Only the poly count of each cluster is dynamic. The surface area of each cluster is fixed at the time of asset creation during the import of pre-processing phase. Poly count of each cluster dynamic adjust in real time based on the camera's distance, which I understood this part. Closer clusters use more polygons, which is intuitive. Higher LOD level of detail, while distant ones use fewer. Cool. Cluster surface area static. Once clusters are defined on an object, their boundaries don't change during gameplay. Each cluster comes on certain portion of the object surface, and that does not change dynamically. Cool. So what I understood here is that oh, I wasn't sharing the GPT screen, but okay. I got the hunch, like if this while making the asset only, I'll decide how what would be the surface area of the cluster. If I want more detailed object, then I'll reduce surface area of the clusters, right? And if I don't want so much detail in an object, irrespective of whether it is close or far, then I'll increase the surface area of the clusters. So that is about the Nanite engine. Basically, it gives you that sense of continuity rather than keeping things so discrete in the earlier approaches, right? So this is what is the novelty of Nanite engine. I'm not sure if other engines also use it or not. I've just found about this Nanite engine and got to know that this is what is used, right? This article also has some explanation of the rasterization. Uh, so rasterization is basically what I understood, projecting like the process that there is a 3D model, right? It has certain polygons. So I'll just project it into the 2D screen. I'll check if this 3D model's 2D projection fits in the camera's view. If it is out of the view, I won't paint it. If it is inside the camera's view, the rectangle or whatever is formed by the camera's view, then only I will paint it, right? And maybe and there are certain algorithms used as well to paint these pixels. So there are certain interpolations, and also suppose I've got the three vertices, and I know the color of these three vertices. How do I paint the intermediate, how do I paint the whole triangle instead of just painting the vertices? Uh, that can be done by simple interpolations. Uh, so that is also what I learned. Yeah, that's all. Uh, it's a good learning for me. I've, I can say I have understood a tiny bit of how nanite engine works under the hood. Yeah. Okay. Thank you. Bye bye.